This is a video tutorial for Tutorial 3A Question 8. Tutorial 3A Question 8 gives us two curves, C1 and C2, and asks us to sketch them on the same axes with the equations of any asymptotes shown. So firstly we will key in C1, which is y equals to x minus 2 over x plus 2. I'm using GeoGebra for this. You obviously can use your graphing calculators. From the graphs we can see, and from our own knowledge, that we're going to have asymptotes x equals to -2 and y equals to 1. The second equation, we also need to state the points of intersection for any points of, the coordinates for any points of intersection with the axis. Your GC can help you find these. GeoGebra will do it for me, but you see that it is 0, -1, and 2, 0. We then have to key in the equation for C2, and that's going to be x squared over 6 plus y squared over 3 equals to 1. And we see that we get this oval here. So we also need to key in any points of intersection with these axes. These ones are a little bit harder to show, but what we have here at this end, so the equation is x squared over 6 plus y squared over 3. So this value here would be the positive square root of 6. This would be the positive square root of 3, negative square root of 6, negative square root of 3. So I might just write that out again. Export graphics using clipboard. Let's come over here. Let's paste that there. So we can now see that we would have this value here would be positive square root 6, positive square root 3, negative square root 6, and negative square root 3. And so those are the points of intersection with the axes for our graph, C2. So the next part asks us, part 2, asks us to show that any x coordinate of the point of intersection of C1 and C2 must satisfy some given equation. So to do this, we're going to substitute C1, or the equation for C1, into C2. So by doing that we can find the equation which the x coordinates need to satisfy. So if you recall, C1 is the graph of the equation y equals to x minus 2 over x plus 2. C2 is the graph of the equation x squared over 6 plus y squared over 3 equals to 1. So I'm going to sub C1 into C2. That means I get the equation x squared over 6 plus 1/3, and I'm just going to pull the over 3 out the front, and then I get x minus 2 over x plus 2 squared equals to 1. So x squared over 6 plus 1 over 3 x minus 2 squared over x plus 2 squared equals to 1. I don't like all these fractions, so I'm going to multiply through by 6 first of all. That gets me x squared plus 2 x minus, I still have a fraction there, 2 x minus 2 squared over x plus 2 squared is equal to 6. That's just multiplying through by 6. Now, if at this stage I want to look at what I want to end with, which is 2 x plus x minus 2 squared equals to x plus 2 squared 6 minus x squared. Now I see I've finally got an opportunity. Like, I've got my x minus 2 times 2, that's this part in here. I've got my x plus 2 squared, that's down the bottom at the moment, but I can get that up quickly enough. Now all I need is the 6 minus x squared. Well, I've got my 6 here, I've got my x squared here, so my next step is going to bring the x squared over to give me 2 x minus 2 squared over x plus 2 squared is equal to 6 minus x squared, and then multiply up, I get exactly what I want. 2x minus 2 squared is equal to x plus 2 squared, 6 minus x squared. So we have, that is what we set out to show. Final thing we need to do is use our calculator, our GC, to find the actual value of these x coordinates. So I'm going to just hide A and B here for a minute, and we're going to find the points of intersection between the two. So I can do that just by clicking on your GC. You'll use the point of intersection. Hold on, let me just check that I actually got that. I did not. So you guys will do that on your GC by looking at intersection. I'm not actually sure I can do that here. Maybe I can. Not sure if I can. Intersection of F and C. There we are. And we get these two values. So let me just change my rounding to 3 significant figures. And again, you can see points C and D, these are my answers. So you can get that on your calculator using the point of intersection. That is it for question 8.